This. Screen. Screen. Hi, Christine. Screen. Yup. 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 Yep. Yep. Alrighty. Goal today. One second, guys. Okay, gotta show Christine. Alrighty. Fuck noodle. Alright, where's my nipple? Come on. Does it look like it's running? Oh, the machine died.
window open, the phones do shake. I won't wait for you. It's the middle of the night, but the street lights keep me awake. I feel like a fool, 'cause I leave the window open, the phones do shake.
Old photos. Let's see, paper 2HL. Oh, these are cultural. Hamiltonian cycle. Oh no way! AI is chilling. What the hell? I don't know why it's not turning on.
Street lights keep me awake. I feel like a fool, 'cause I leave the window open, the phones do shake.
Turning. Gears are turning. Gears are turning. Hell? The goal is to continue. Yes. That button. That button means we're on. We have not done integrals. Honestly, let's just get through all the past papers before we do the integrals. The lecture and some questions are done. Gym is done. We did these yesterday. Raymond sums, testing p-test. Yep. I don't even remember this one. Please. Hey, we're good. We are online. Took 10 minutes. 11. Honestly, getting through 1 or 2 questions is better than 2. I really want to get through like lag. We're halfway there. Holy shit. Also, because we're streaming, it's like taking its toll on the Wi-Fi connection. Come on. house and elimination. We're going to go through level 1 through 1. Hi Christine. Hi Christine. Yes. You've got the screen on the side, got the webcam, got the iPad screen. So boom. Rồi. Nó không có vào. Thường nó phải dễ chứ. Lát rồi. I like this. What's going on? Anna. I don't like this. bro. Not what I signed up for. Something's going on. Okay. Doesn't show that there's a connection. There you go. Charging there might be a problem with charging. Honestly, I don't even do want it like locked in. We're ready to go. Come on, let's hit the road. I really don't like this. Okay, I'm gonna send some money to Nguyen. Thank you. Instantaneous rate. Okay, let's continue. So from actually, how do I do want my sorry, I'm fiddling right now because I really I really like this. I'm gonna put this like right bottom left, and I'm gonna maybe scale it up. This much is a good number. To the corner? Yeah. Yeah, that's fine. That's fine. Ah! Close my eyes. Let's work. I see it, so it's nice. Okay. Algebra. Yep. This. And we're scrolling to complex numbers. Let's go to the bottom end of complex numbers. Also, look at these questions I haven't done. These are complex polynomials that I want to get done this week. Plus complex like that pushes us over the edge for like the 80% that matter. Let's continue. Core exam group. Okay. So, two weird things. the modulus is 0.8 to the 5th, but this is not to the 7th. Here, so find the modulus of w, right? And there's the mth root. So modulus of w is like, these are like more general solutions, I'm assuming. And this is like the nth root of z. So if it's z, find modulus, right, of the nth root of z, right? Then that implies that we're looking at one of the points, and then we can read them from the map. Right? Whereas the modulus of w, here, if you guys see this, this is alpha, right? So alpha is this. So the modulus of alpha we can read off on the readable off polar grid. That's what I assume. And then the this part here is of w. So w in itself is that big complex polynomial. This is why I need to do complex polynomials. Okay, so the modulus of w is that, but then to the 5th root. Because if you're given like a 0.8 e and fucking 3 pi on 4. Sorry, what is it? This one. 1, 2, 3, 4, 5, 6. So 6 pi on 24 is pi on 4. Right? That's W1. And this is 8. Sorry, M1? Yeah, W1. Right? So let W be the R E I theta plus 2 pi on 5 ki, right, for k 0, 1, 2, 3, 4 or something. Then the root of that is that, but then it's like, I'm assuming general solution, right? Then it's 0.8 e pi on 4, or pi on 4 usually to the 1/5 is equal to 0.8 to the 1/5 times e pi over 20. Is that right? Why are we doing minus 3 pi over 4? Fuck! Sorry. Not locked in. Let's read. And let's just make sure I know what we're trying to... Algebra notes in Maple. Yeah, this is gonna be hectic when the final exam comes. Maple notes are out. For a general root, for a general modulus of a complex polynomial, in the form, I was gonna find it from the algebra notes. Actually, I'm gonna read it. It just means I didn't pay attention to it yesterday. Now that I look at it. Mathematical induction, induction. So alpha is the specific root of the thing inside. Factorize. Like, imagine this as W, or like W beta. Damn it. Right? Imagine that as W beta. Wait, what happened to my screen? Oh, it's right there. It's okay. And this is W. So W is the complex number. Okay. 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 Z and W are complex numbers, and alpha and beta are the specific roots at k is equal to some integer, right? That's why argument is minus 3 pi and 4. Principal argument of W. So smallest positive principal argument is right here, which is pi on 4, right? Yes. 2, 3, 4, 5, 6. Yep. Pi on 4. And then we have to... pi on 4 is the starting argument, right? Plus 2 pi k I 5. Right? But why are we multiplying? So the argument is 5 times the argument of any root. Five times. So n times the argument. Argument of W is equal n times the principal arc of W of a root. So arg of W is equal to 5 times, okay, pi on 4 is equal to 5 on 4, and then you have to minus pi, right? So this is 8 over 4, so this is minus 3 pi on 4, pi. Okay. Valid. That's fine. Here you go down to enter the corresponding letter from the plot above. Will A times B right? So now we have, we have alpha, right? This is alpha, 0.6. Okay, I'm gonna use black. Yep. Alpha is equal to 0.6 and beta is equal to 0.8, right? If we multiply this together, we know from our multiplication that it's the same, right? Or like if you multiply, you multiply. If you divide, you divide, and if you divide, you divide. Right? This should be simple. Wait, no. Is alpha the whole thing? Yes, alpha is the whole thing. Okay. It's okay. Complex numbers are chill, bro. Right? We just go like alpha is equal to 0.6 times exponent of this. Please, I just tried to put it in. Wow, okay. It's laggy when I'm at home. I feel like I should connect this something to the screen. Okay? So that's my first. Oh, I have to have I. 1, 2, 3, 4. 4 seconds. Okay? And then our beta, I'm gonna write down here. That's our first one, but then our principal argument is pi and 4, right? And then this is pi and 4, and then k plus 2k pi I over 5, right? And this is when k is equal to 0. This specifically. You guys see this one? So if k is 0, k is minus 1, k is minus 2, right? So it's pi over 4 plus 2k, 2 times minus 2, right? So minus 4 on 5. All to I, sorry. Yep. I'm just gonna make sure, ChatGPT will do, I don't even know anymore. Okay, that's minus 11 pi over 20. So it's equal, that's our beta. Our beta is equal to 0.8, right? Yep. E to the minus 11 pi on 20i. Okay? Looks pretty, looks neat. Not too bad. Then, these two, I'm just gonna write that beta equals 0.8 times exponent minus 11 over L times pi over 20. I forgot my I. It's okay. Over 20. Is that a minus? Both minus, right? Yeah. Okay, that's fine. Please load. Only problem with these questions at home is it's just not loading right. When I go to school, it's just like, yeah, okay. Okay, so they just move the minus sign. Now a times b, so I'll just do a times b. Is 0.36. So we're looking at some part here with it's 0.36. Wow, they're actually not. They don't want us to. Sorry, 0.8. My bad, guys. Okay, maybe I need to do something about. I need to learn how to add complex numbers. So, complex numbers. Complex arithmetic. Show me. Whatever, bro. Man, fuck them. I mean, so I just have to add these. Sorry. I'm gonna kill myself. Oh my god. You guys see this? It's like, this is how slow the screen is moving. Oh my... Okay, something needs to happen. How do I buff something up? Okay. This is not funny. Yep. Minus 11. That works. Okay. So it's a little bit. It's like a little bit over, so I'm guessing it's n. Right? It's a little bit over pi here, or negative pi. Right? So you're starting from here, going somewhere in n. Right? And then a divided by b. How do I... Or I could like turn these guys into complex. Could I do that? Come on, bro. Come on, bro. Work, you computer. With linear algebra. Kill me now. Oh. I'm cooked. You see that L? It's gonna take forever. 2, 3, 4, 5. Let's see. You guys won't be able to see that, but I'm trying to find complex numbers. Complex. Not really. I guess not. How do I run this better? This is gonna take forever. This is gonna take forever. Okay, conjugate of B. I'm assuming it's like right here. So this is P. I times alpha. If you multiply something by I, it probably goes up here. No, I actually don't know. How can I add in Euler form for complex numbers in Maple to complex arithmetic, or in polar form? Fuck. Come on, bro. Log work, bro. I might do the thing from my computer. Holy shit, I might do the thing from my computer. This is killing me. Are you seeing this? A divide B is equal 0.75. 0.75. This circle right here, right? 0.8, 0.9, 0.8, 0.75. This looks like a possible one, and this looks like a possible one, and this looks like a possible one. And so it has to be these guys minus. So I'm just gonna subtract here. And we see a very small thing, so it's L. And B divided by A, B on A, this should not take as long as it is. It does take 5 marks. Okay, I think I will use my laptop. How will I connect it? Will I connect it? Hello? Okay, DNA. Okay, it's working faster. 1.5. Oh, sorry. 1 1/3. So out of these two. And then because it's going to be the argument here minus this argument. Sorry, minus the negative of that argument. Please, bro. Okay, minus 13. So it's like right here. So it's A. The complex numbers are plotted below as blue dots in white labeled letters. B conjugate. How do I find this in? Pretty sure I can just like convert. Right as. Show me. I theta. Here. Could I do that? Simplify. Okay. Simplify. I times A. Hello? Please, brother. Brother, please. Brother! Run the word simplify. A times I. Close bracket. Okay. Oh, actually, that's a lot better. Right? 0.6 times 0.2, so it's K. Oh, this is a lot better. K. Going into a rectangular form is a lot nicer then. Because I can always just like, you know? How do I be conjugate? Conjugate. Conjugate of that. Okay, simplify the conjugate. Are you guys seeing this? I'm sure you guys are. But I really don't like it right now. Okay. Conjugate of B. Supposedly. Okay. Okay, never mind. Simplify. Conjugate of B. Minus something very small plus 0.7. This is out by 1, so it's actually m. Sorry guys. And then a squared is simplify a squared, which is great. Oh my. A squared. Please. Simplify a squared. Minus 0.35. Yep, G. Okay, so this question should take like 5 seconds. Honestly, this is a points grab. If you guys are seeing this, this is a points grab. We use simplification. Could I simplify this right here? If I could simplify this, then this does become a really nice points grab. And the only like part that I needed to know was just this. And it's just like it's not about even it's not like tricky. It's just okay, 0.7 plus 0.05. So could I have seen that somewhere? That A times B, right? Is minus plus 0.5. Yeah, okay. So I could. Okay. So just writing up notes real quick. Text. There are roots of the complex number. Sorry, there are modulus of the complex number or the modulus of the roots of the complex number. So because it's modulus of that, or it's modulus that, then because they are the fifth roots of W, so W must be to the power of 5, must be multiplied to the power of 5. This is okay. Nope, not what I wanted. Text. because the roots are because the argument of the root is at pi on 4, we also basically have to multiply by 5 to get the argument of w instead, right? Because when we are taking the 5th root of w, we are multiplying in 5 to the exponent. Okay? Clear? Right? W is some re theta theta I. Then root is the r to the 1/5 times e that times 1/5, right? Right, so this is how we're going here. Root. Then to go back, we must, to get r, let's name this r1 and let's call this rw and theta w. Right? Then theta w is equal to r over 5th once again to the 5. To cancel it out, we get back rw, and e that this specific that has to times 5, whereas this one is r to the right, and then this one I times a half times. Let's make this n. This is a diagram that I'm commit this to memory. Okay. Wow, that took 50 minutes. Fuck! Sorry. Okay. By the way, you guys would be able to see it if I just show you guys right here. These are the answers. Yep. Okay, I've done this question. We're on 66. I want to kind of get most of it done. Okay, I will color this in, actually. Something to take note of. I did a lot of the calculus questions. Honestly, points grab. Not nearly as theoretical as the questions from 1141. These must be a points grab. Okay, let's do this one. Right, we're given ABC, and they're telling me to find C minus A, right? I could do it by hand, I could do it by maple. I'll do it by hand. Because chances are if I do it by maple, it's gonna be slower. Yep. So BC is equal to minus 3, 1, 1, minus 0 minus 1 minus 1. Minus 3. 1 plus 1 is 2. 1 plus 1 is 2. Okay. Minus 3 to 2. Which of the following statements is true? The angle at vertex A is a right angle. So they want us to test the dot product of these. So vertex A here, right? Vertex A is right here, right? Because that's A, B, C, right? The vertex A is this. So they want to test AB dot AC. That's 1. They want to test sorry. They want to test AB, sorry, BA dot BC, and they want to test CB and CA, right? So now it's actually better to do it in Maple because it's a lot faster. I want to start a new worksheet. Okay, that A equals 2, 1, 0, close. Let B equals 0, minus 1, minus 1. And let C equals minus 3, 1, 1. Okay. Then it's quick that we can just go like BA dot CA. Or B, yeah, right? So that's AB to AC. Is that. And we see that's 9. So that's not a right angle. I can just go A minus B dot C minus B. As long as as long as this is the same, we know where we're going, right? So this is vertex B. So that's 0. That's perfect. And because this is a multiple choice, that's 1. The following definition theorem from the course notes must be used to answer the question below. Okay. This is a mean value theorem. Suppose that f is continuous on AB, then f has a global maximum and okay. So this is max-min theorem. My bad. Let f be a function, R be a differentiable function that has no stationary points. So it's basically strictly increasing or decreasing, right? So you guys can think of some function f. It's either like it's like that or it's like this. Is what they're saying, and none of the slopes is at 0, right? So we see that point C is a critical point. Suppose that f is continuous, then f has a global maximum, global minimum, where the global maximum are both critical points. So it's like there. Okay, the triangle is this. The side AB, the side AB, A to B, right here. So they're describing this function. Sorry, A to B, yep. Is this. And some of the descriptions can be given for the sides AC and BC. By referring to the definition and theorem and other results required, explain why the maximum theorem values of that on the boundary must occur at its vertices. Okay. By referring to the definition and theorem and other results. Explain why the maximum and minimum values of f when we put x plus 2y minus z okay, on the boundary triangle right. So what they did here for f of x plus 2y minus z, they have x is 2 minus 2t, right? Y is 1 minus 2t, and z is minus t, right? 2 minus 2t, let's just make sure, minus t, right? So plus t, minus 2t plus 2 minus 4t plus t, right? This is 4, and this is minus 6 plus 5, plus 1. So that's 4 minus 5t, like they said. So now they're saying explain why the maximum and minimum values must occur at its vertices. That's like the most retarded question I've ever heard in my life. I mean, would I differ? No, let's see. Why are they doing the calculus in vectors? There's that one question about the identity, if you guys know what I mean. It's the quadratic. Is it this question? No. Yeah, it's a parametrization question. It's this question specifically that I chose not to do. This question. No. This one. Pt is equal to 1 minus ta times tb. This is called the linear interpolation of vectors a and b. A parametric vector equation for pt and evaluate p0 and p1. And so we have f of 4 minus 5t is equal to 1 minus 4 minus 5t is what I'm assuming, right? I'm basically setting this as this right here. So I'll just write this up here. Pt is equal to 1 minus ta plus some parameter tb, right? Times a plus 4 minus 5 tb. That's what I'm assuming. Is that something we could use? Maybe we could write that in. Right. And then we could show at 0 and at 1, or something about like let f r to r be a differentiable function that has no stationary points, then the function is not equal to 0, then the derivative of the function is never 0 for all r, implying that it is strictly increasing or decreasing, something like that. That's one. You could get a mark for that, I'm assuming. Let's actually solve the question we're looking at first. 1 minus 4 plus 5t. So this is minus 3 plus 4 minus 5t. Is that a value to us? Must occur at its vertices. By the way, occurring at vertices is at f, like at t is equal to 0, f of 4 is equal to minus 3 plus, minus 3a plus 4, something like that, maybe. At t is 1, f of something like, we can, honestly I don't know how to answer this question, but let's say if I were in an exam, I'm gonna write something like this. We can use the linear the linear there, that's what I'm assuming. Curve something like that, and the side AB then the side AB is continuous. Then suppose that the parametric form equation of the side AB parametric form equation of the side AB suppose that the parameter is, then we know the is also has no stationary points, and that it is strictly increasing or decreasing by the max-min theorem. the equation of the line segment AB for t in 0 has a maximum and a minimum because its interval is closed and it's continuous, I don't know, on all the intervals. We use the linear for f is minus 5t plus 4 to get f. That's what I'm assuming. Honestly, I don't know. If to get that is equal to minus 3 a plus 4 b, where a is our direction vector, is our position vector, and b is our direction vector. Substituting t for 0 and 1, we get both ends of the equation. It's fucking, since it's linear, we get both. Does that work? I don't know. Maybe I'm overthinking it. At t is 1, 4 minus 5 of 1, yep, is equal to minus 3 plus 5a plus 4. So that's, is that minus 1t? Right? That is f at minus 1 is equal to minus 2a plus. Maybe I'm overthinking it. I mean, because it has this. That's why it's so, like, it's so weird. At t is 0, f of 4 is equal 3a plus 4b is equal to, let's get this, minus 3 times a plus 4 times b. I don't know, something like that. Is equal to the vector minus 6, minus 7, minus 4. At t is 1. Maybe I'm shitting myself. Minus 2 plus minus 1t. I don't know. Minus minus 4 minus 1 1. Similarly for AC and DC. I don't know. Okay. I've tried it. We're gonna get ChatGPT. Hey, am I using the linear curve at the wrong time and place when trying to That's it. Yes, bringing in is unnecessarily. Fuck. My bad, bro. My bad, bro. So does the thingy with the function not matter if it's degree polynomial 2, but could anything go wrong? Okay. Seems like we went way too off topic. Okay, so there's okay. So I'll show you guys. Up until this point is okay. Let da 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 da. So I have to show that? Okay, but because the function doesn't have any stationary points as its critical points, the Max-Min theorem states that and f is differentiable for all, then the only critical points will be the endpoints of 0 and 1 for t, which will give us the maximum and minimum values. Geometrically, this is a line, a linear straight line with parameter t. For t is 0, f of 4 equals answer f of at t is 0 and t is 1. Oh, and for t is equal to 1, f is equal to 1. So, and which correspond to the vertices A and B. Similarly, for B, C, this will also be the case. I don't know. Weird question, honestly. Weird question. Not much to do, actually. Seeing question E. Algebra. Seeing questions for group. Page. Yep. And parametrization of vectors and calculus. Max min theorem.
differentiators has been accessibility and
Oh, it's totally differentiator. In the beginning, when you're not very good, you do that because you say, hey, you know, you could go to these guys because you're just a number. With me, you get my cell phone, right? But at some point, you get big enough that you're like, okay, you get my cell phone means I'm good enough and I'm relevant. So I think we should change the expectations of delivery. So if they said yes to it, just stick with work in progress. And that might just mean that you just need to learn a script and how do I deal with people who ask for my time, which is like your documentary resource or your relevant to your fellow company next time. The way you're going to pitch it is that you're going to get even more, but rather different. And so whenever I've done a delivery change, I don't position it as, hey, I'm going to do less of what people like. I'm going to say, hey, I've listened to all your feedback, and I'm actually going to change this in a way that benefits what we got here. So this way I can reinvest in these things that you which is a process that's going to happen for you. You lose some people, but that's okay. Because you will have room for better people who paid more and didn't come in with the old expectations.
And it's 6 people. If you lose 6 people, then find 6 more people. Right, hey. Work out these first. The rest of senior exam question bank consists of questions below, except for core questions that may be repeated below. There will be a section of these questions for 30 marks of your exam. And then out of these, we want to like look at the unseen ones. So we'll run through all of them, and then we'll see, hey, which one is like a clear differentiator that it's like way outside the course. I mean, if I get this, I passed the exam. I mean, I passed the course. If I get through this, I get a D in the course, or a HG in the course. And then if I do all the hards, then I get really high marks in the course. So this doesn't seem like the answer here. Different. It is 12. I will get hopefully 2 more. So there's these Tanch questions. Never done it. Kosh. I haven't done it yet. We'll study the content on it and then do it. Okay, let's do this. Matrix. Okay. Matrices, great. It's actually going to the end of matrices, but all relatively elementary questions, yeah? Crikey. See, a lot of hard. Jesus Christ. Hard. A lot of hard show that questions, okay. A lot of 1141 questions. Okay, it seems like a lot of the hard questions come. Factorize the determinant. That I don't need to do. Okay, so I can delete this page off of. Here, see this? It's all X, right? We're gonna delete it. What we do hope to do is this question, this, right? These are prove that questions. So we really want to go into the deep end. Okay, let's clear these babies up. Sorry. Boom. Yeah. Lock. Yep. That's what I do. Out of sight, out of mind. Lock. Right? And it's just like, sorry. Ooh. Okay. I do see the X, but it just cuts it down a lot for me to do. post this. Yeah, past papers is okay. Core exam bank. Consider 4 n by n matrices. A, B, H, P. Matrix B is obtained from matrix A by multiplying row 1 by 5. What fact is true for this row operation? Yeah. Is that possible? I actually don't know. Okay, so I haven't learned about the term like this much. Like, oh, okay. Matrix B. Oh, so everything down from here is the same, and then they're multiplying this row by 5. So this is A. No, this is B. B is equals this, and A is equal to this. Yeah, I don't know yet. We'll see. Okay, let's think. The determinant is this, right? Sorry, the determinant is just this. It's a number. So if I need to multiply A by 5, it seems like it has to be this question. This question. If not, it has to be one with the 5 in it. Okay, that means I don't know it yet. I'll note this question down. Question 16. I don't want to go through the questions. I don't want to attempt them if I legit don't have anything to do. It is also a matrices question. Maybe I could attempt these because he's gone through like 2-on-2 matrices. A squared is equal to minus 3a plus 2i. And b squared is equal to 3b minus 4i. Okay. BA is 3a minus 3b minus c plus 6i, and ABA is that matrices A cubed and A inverse can be written as linear combinations of A and I. Okay, so we want to find A cubed is equal to A squared times A, right? Is equal to, so I do want to find what A is. C is, I do want to find what A is. This is me thinking. If BA is equal to 3A minus 3B, oh. Okay. Well, BA is equal to 3A minus 3B minus A times B plus 6I. Right? Oh, okay. This one multiplied by this one is something of this one, right? And if we can get it, we can find A. If you guys know what I mean. Like, this one is part of this, right? So if it's A minus this one, then this one minus the inverse of A probably has to be something. Right? I know A, B, A is equal to minus 3A minus 2B plus 6I. I feel like these are... I don't need them right now. It's this one, it's this one. Okay, I've put AB into this. Definitely. BA is equal to A inverse, right? Times this. Let's just try it first. A inverse of A and BA is equal to A inverse minus 3A minus 2B plus 6I, right? Then I can multiply in. That's my assumption. Like that. Right? So that's equal to BA. That doesn't look like it's equal to BA. Oh my god, so I could divide. I'm trying to find these. Could you show me how you would be finding them? I would put it in like a really nice image diagram of the matrix, like operations or the arithmetic that you would do, so that you would do it, so that you could get to your answer. And don't just like write it up in the image. Write it up in the image. I like when ChatGPT makes images. I mean, after some time, like, I would assume that, like, it wouldn't be hard to let's see. Fuck, man. See, determinants is last. 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. A lot of hard questions. Association law. Right, mate? Let's move on. Very moho. Okay. Vectors. Distance of vectors, projection of vectors. Nice. Point normal form. Plane 1. Plane P1 is in parametric vector form. Use these spans in cross product and the triple cross product to find the normal to the equation. Then you have the equation in point normal form. Right? How many marks is this? 2 marks? 5 marks? Oh. Let's think about this. Because I mean, I was good with vectors, but I do need to write up my notes on how they work again. choose points, 4 points XYZ by inspection. You could choose points that correspond to a valid Cartesian equation. For instance, 0, -1, 0